Okay, so for Math 9s today, we are looking at linear graphs. So a linear graph, it's a straight line graph. It can be a horizontal line, a horizontal straight line. It could be a vertical straight line. It could also be a diagonal straight line. The general form is y equals kx, where k is the given constant value. Now, in these modules, you see it as kx, but in the future, you will see it written as y equals mx plus b. So today, because we're working through the module, we will see it as kx. So the linear graph, it is an example of direct variation, which basically means that as the value of x changes, the value of y changes as well at the same constant rate. All right, so here are two linear graphs. This is a positive linear graph, so we have a positive x value here. And a positive linear graph going from left to right is going in the upward direction. If we have a negative linear graph and we look at it from left to right, it's going down. So it would have a negative k value here. Okay, so a table of values is used to draw graphs. So basically you're going to select x values and then put them in a table of values, and then you're going to use substitution to determine the y values. Once you've filled that graph or that table of values, you can now make your coordinates from those x and y values. You can then plot them on the grid and then join the points to make your graph. The locus is basically the description of the graph, and therefore it would just be a straight line in these cases because we're looking at linear graphs. So let's take a look at this example. So we have to draw a graph for the function y equals 2x. So what we're going to do is we're going to choose values for x, and usually you're going to use values, small values like 0, 1, 2, 3, and you can use -1, -2, -3. So let's choose these values for x. So let's choose 0, let's choose 1, 2, 3, let's choose -1, -2, -3. So just using small numbers is usually beneficial. So now we know that our y is equal to 2x. We've already chosen x values. We can substitute them into our equation here and figure out our value for y. So for example, here we would say, I'm just going to put it on the side here, y is equal to 2 times 0, which is 0. So 0 and 0 would be our first coordinate. Now we would substitute 1 in for x. So here we would get y is equal to 2 times 1. 2 times 1 is 2. So here our value would be 2. It looks like a z, but that's my 2. Next is 2. So y is equal to 2 times 2, which gives me 4. And then we would continue. So here it would be 2 times 3. So we would get 6. When we have -1, -1 times 2, that would give me -2. -2 times 2 would be -4. And then -3 times 2, which is -6. So basically, by doing this now, we have coordinates for our graph. So our first coordinate here would be 0, 0. Here our coordinate would be 1, 2. Our third one is 2, 4, 3, 6, -1, -2, -2, -4, and -3, -6. All right, so once you have your points, you can just go through them and plot them. So for example, our first one would be 0, 0. So right there would be 0, 0. And then 1, 2. So over 1 up 2 would go right there. Next we have 2, 4. So over 2 up 4, 1, 2, 3, 4 right here. And then 3, 6. So over 3, 1, 2, 3, up 6, 1, 2, 3, 4, 5, 6 right here. And so on. Negative 1, negative 2, negative 2, negative 4, and negative 3, negative 6. All right, and then you could choose, let's see here if I have this, and then you can, oh, that's not right. You can then connect the dots together and make your graph. And because this graph, it would continue in both directions, then we would put the arrows at the ends of that graph. Here we would get negative 2 times 0, that would be 0. Negative 2 times 1, negative 2. Negative 2 times 2 would give me negative 4. This would be negative 6. And then we would have our positive y values here because negative 1 times negative 2, that would give me positive 2. Negative 2 times negative 2, that would give me 4. And then this would be 6. So these would be our coordinates. So we would have 0, 0 as our coordinate. And then we would have 1, 1, negative 2. I put negative there, but that is positive. And we have 2, negative 4. We have 3, negative 6. Negative 1, 2, negative 2, 4, and negative 3, 6. So those are our coordinates. All right, so quickly, that would be our 0, 0, positive 1, negative 2, positive 2, negative 4. Already we can see that this is a downward graph, which is what we should have seen because our value here is a negative value. Let's just plot some of those points here at negative 1 and 2, at negative 2 and positive 4. All right, so we can see it is going downwards, which is what we were expecting because that value here is negative. And we can put those arrows to show that that graph continues on both sides. For this example, our graph is for y equals 3x minus 5. So again, we would just use our values for x. I chose 0 as my first value for x, substituted it in our equation for x. So 3 times 0 is 0. 0 minus 5 gave me negative 5. So that would be my first point on the graph at 0, negative 5. That would be the first coordinate. If we had, for example, choose 1 as a point, that would be 3 times 1 minus 5. So 3 times 1 is 3. 3 minus 5, that would give me negative 2. So that would be my next point here at 1, negative 2. And that would continue on. All right, lastly, we're just going to look at this problem here. The student council is planning to hold a dance. The profit in dollars is 4 times the number of students who attend, minus $200 for the cost of the music. So first question, A, would be write an equation that relates the profit to the number of students who attend. So we're going to choose variables here. We know that it's 4 times the number of students minus 200. All right, so choosing variables, so we can let n represent the number of students who attend. P will be the profit in dollars. So our equation would be P is equal to 4N minus 200. So you can still, just like we've done before, is create a table of values. So again, choose the number of people, if 0 people attend, if 50 people attend, if 100 people attend. So substitute that into your equation. So if 0 people attend, it'd be 4 times 0 minus 200, which gives me negative 200. If 50 people attend, we end up with 0 for profit. And if 100 people attend, we end up with 200. So there's our table of values. So we can graph that. And then the question is, does it make sense to join the points? So we plotted the points here, 1, 2, 3. Those are the points on the grid. And this is just showing that using a straight edge, we can see that it is a straight line, but it does not totally make sense to join the points. For example, 82 students can attend, but you'd never have half a person attending. So you can't have points for 82.5. So therefore, these points will not be joined. All right, this is called discrete points. You can't join the points because it doesn't make sense to join the points. Again, because in this case, half a student cannot attend this function. How many students have to attend to make a profit? So if we go back here to our values, we saw that if 0 people attend, we're actually in the negative value for profit. If 50 people attend, our profit was 0, right? So we have to have at least more than 50 people attend. So here, profit is greater than 0 when the number of people is greater than 50. All right, so at least 51 or more students have to attend before a profit can be made.